The internet has revolutionized how we store and share information. We rely on it for everything from cat videos to critical financial transactions. But this reliance comes with a cost. Centralized servers controlled by tech giants hold the keys to our digital lives. Our data is vulnerable to hacks, breaches, and manipulation. This centralized control raises concerns about privacy, security, and censorship. Imagine a world where our data is truly ours. A world where we control our information, free from the whims of corporations and governments. This is the promise of blockchain technology. Initially designed for cryptocurrencies like Bitcoin, blockchain's potential extends far beyond finance. Its decentralized and immutable nature offers a new paradigm for data storage and management.
The journey began with a simple question. What if we could leverage the power of blockchain to store any type of file? This question sparked the creation of NanoCheeZe, an experimental blockchain designed to test the limits of this technology. Built upon the foundation of Litecoin, an established cryptocurrency, NanoCheeZe provided a sandbox for innovation.
The goal was clear: to develop a system capable of uploading and storing files directly on the blockchain. This meant overcoming significant technical challenges. Blockchains, by design, are best suited for handling small pieces of data, like transaction details. Files, on the other hand, can be massive, requiring innovative solutions to make them compatible with blockchain structure.
Creating a blockchain from scratch is no small feat. It's like building a digital skyscraper, meticulously laying each brick of code, ensuring stability and security. NanoCheeZe, built upon the Litecoin framework, inherited the robustness and reliability of its predecessor, but this was just the foundation. The real challenge lay in adapting this foundation to accommodate the unique demands of file storage.
The team behind NanoCheeZe understood that blockchain's true power lay in its decentralized nature. Unlike traditional file storage systems, reliant on centralized servers vulnerable to attacks and failures, NanoCheeZe aimed to distribute file data across its entire network. This meant that even if one part of the network went down, the file would remain accessible, replicated across countless other nodes.
The process of uploading a file to NanoCheeZe was akin to assembling a complex jigsaw puzzle, each piece meticulously placed to form the complete picture. The first step involved dividing the file into manageable chunks, each chunk small enough to fit within a single blockchain transaction. This was crucial as each transaction on the NanoCheeZe blockchain, like any other blockchain, needed to be verified and added to the ledger.
Once the file was divided, each chunk was assigned a unique identifier, a digital fingerprint that would allow for its identification and retrieval. These identifiers were crucial as they would serve as the links connecting the various file chunks scattered across the blockchain. Imagine these identifiers as breadcrumbs, leading from one chunk to the next, ultimately guiding the user to the complete reassembled file.
With the foundation laid and the code meticulously crafted, the moment of truth arrived, the first file upload to the NanoCheeZe blockchain. The team held their breath as they initiated the upload, a simple text file containing the words, "Hello World." This seemingly insignificant message carried the weight of countless hours of work, representing a giant leap forward in the world of blockchain technology.
The file, broken down into its constituent chunks, embarked on its journey through the NanoCheeZe network. Each node, upon receiving a chunk, diligently verified its authenticity, ensuring that it matched the cryptographic fingerprint assigned during the upload process. This decentralized verification process, a hallmark of blockchain technology, ensured the integrity and security of the uploaded data.
NanoCheeZe, while a groundbreaking achievement, was just the first step in a much larger vision. The ultimate goal was to make this revolutionary file uploading technology accessible on established, widely used blockchains. This meant bridging the gap between the experimental world of NanoCheeZe and the robust, yet somewhat rigid frameworks of Bitcoin and Litecoin.
Enter MEQUAVIS, a software application designed to do just that. MEQUAVIS acted as a translator, a bridge between the unique architecture of NanoCheeZe and the established protocols of Bitcoin and Litecoin. It was like teaching these older, more established blockchains a new trick, expanding their capabilities to encompass the world of file storage.
The compatibility of MEQUAVIS with Litecoin opened up exciting possibilities. Litecoin, with its faster transaction speeds and lower fees compared to Bitcoin, presented an ideal platform for showcasing the power of blockchain-based file storage.
It was time to put the technology to the test, to demonstrate its capabilities on a grand scale. The team behind NanoCheeZe decided to make a bold statement. They would upload the entire NanoCheeZe executable file, the very code that powered their innovative blockchain, onto the Litecoin blockchain.
This was not just a technical feat, it was a symbolic gesture, a testament to the permanence and immutability of blockchain technology. With the success of NanoCheeZe and MEQUAVIS, the team set their sights on a new challenge, proving the viability of blockchain not just for storing data, but for experiencing it as well. They envisioned a world where music, freed from the confines of centralized servers and streaming platforms, could be accessed directly from the blockchain, streamed seamlessly to listeners around the globe.
This vision led to the uploading of a curated collection of songs onto the Litecoin, NanoCheeZe, and Gasp blockchains. These songs, carefully chosen to represent a diverse range of genres, were not just stored as static files, they were made streamable, accessible through a custom-built web player.
The success of NanoCheeZe and MEQUAVIS on Litecoin and Bitcoin was a vindication of the core technology, but it also ignited a new ambition: to liberate data from the confines of any single blockchain. The team envisioned a future where their file uploading system transcended the limitations of individual blockchains, seamlessly integrating with a diverse array of networks.
This vision led them to explore a multi-chain approach, expanding the technology's reach to encompass a wider spectrum of blockchains, each with its own unique characteristics and strengths. The goal was to empower users with the freedom to choose the blockchain that best suited their needs, whether it was the speed of Litecoin, the security of Bitcoin, or the emerging potential of other promising networks.
Expanding to multiple blockchains was not simply a matter of copying and pasting code. Each blockchain, with its unique architecture and transaction protocols, presented its own set of challenges and opportunities.
The team behind NanoCheeZe had to meticulously adapt their technology, tailoring it to fit the specific requirements of each new blockchain they integrated with. This adaptation process required a deep understanding of each blockchain's inner workings.
The team meticulously studied the nuances of transaction structures, block sizes, and data handling capabilities. They had to find innovative ways to package and transmit file chunks, ensuring compatibility with the specific limitations and strengths of each blockchain. The expansion to multiple blockchains was not just about proving technological prowess. It was about pushing the boundaries of what was possible with blockchain-based file storage. As the technology matured and its reach expanded, the team found themselves breaking new ground, setting records that showcased the potential of their creation.
On Litecoin alone, the team uploaded over 3 million transaction IDs in a single year, a testament to the system's scalability and efficiency. This massive volume of transactions represented not just file chunks, but also the intricate web of references linking them together, demonstrating the blockchain's ability to handle complex, interconnected data structures.
As the NanoCheeZe technology gained traction across various blockchains, a new frontier emerged, one that promised to revolutionize not just how we store data, but how we interact with it, the Ethereum blockchain. Unlike its predecessors, primarily designed for simple transactions, Ethereum introduced the concept of smart contracts, self-executing agreements written in code and stored on the blockchain.
This paradigm shift opened up a world of possibilities for NanoCheeZe smart contracts. With their ability to automate complex processes and interactions, provided a powerful new tool for managing and securing file uploads. Recognizing this potential, the team embarked on developing Modulithic, a new iteration of their technology specifically engineered for the Ethereum ecosystem.
The Ethereum ecosystem, while united by a common blockchain architecture, was far from monolithic. A multitude of Layer 2 solutions and sidechains emerged, each offering its own unique advantages in terms of scalability, cost-effectiveness, and functionality.
For Modulithic to truly flourish, it needed to navigate this diverse landscape, seamlessly integrating with these various platforms.
Moonbeam, with its focus on Ethereum compatibility and developer-friendly environment, became an early target for integration. Its ability to run unmodified Ethereum smart contracts made it an ideal platform for showcasing Modulithic's capabilities to a wider audience.
The team meticulously tested and optimized their code, ensuring seamless operation within the Moonbeam ecosystem.
The integration of Modulithic with Ethereum and its various Layer 2 solutions marked a significant turning point in the evolution of the technology. Smart contracts, with their ability to enforce rules and automate processes, unlocked new dimensions in data security, access control, and even monetization.
Imagine uploading a sensitive file to the blockchain. Not just encrypted, but secured by a smart contract that defines who can access it and under what conditions. This could be a group of trusted collaborators, a specific time and date, or even the fulfillment of a payment.
Modulithic, empowered by smart contracts, could enforce these rules with unwavering precision, ensuring that data remained under the control of its rightful owner. While Ethereum and its ecosystem presented a fertile ground for innovation, the blockchain space was far from static. New contenders emerged, each vying to address the limitations of existing platforms and push the boundaries of what was possible.
Among these contenders, Solana stood out, a blockchain designed from the ground up for speed, scalability, and cost-effectiveness.
Solana's unique architecture, featuring a novel consensus mechanism known as proof of history, promised significantly faster transaction speeds and lower fees compared to Ethereum. This made it an enticing platform for applications requiring high throughput and real-time data processing, including, of course, blockchain-based file storage. Central to this new iteration was the creation of MEQ, a Solana-based token designed to power the ecosystem and incentivize participation.
MEQ would serve as the fuel, the lifeblood of the system, facilitating transactions, rewarding users, and driving the adoption of decentralized file storage on the Solana blockchain.
Unlike previous versions, which relied on the native tokens of the respective blockchains, MEQ introduced a dedicated currency specifically designed for the NanoCheeZe ecosystem.
This allowed for greater control over transaction fees, incentivization mechanisms, and the overall user experience. The magic of NanoCheeZe's file uploading technology lies in its elegant solution to a fundamental challenge: how to store large and complex data files within the constraints of a blockchain, a system originally designed for recording simple transactions.
The answer lies in a process akin to disassembling a grand mosaic into its individual tiles, each tile small enough to be handled individually, yet together forming the complete picture.
Imagine a large digital file, be it a video, a document, or even an entire software program.
These chunks, typically a few kilobytes in size, are small enough to fit within the data limits of a single blockchain transaction.
The real ingenuity of the system comes into play during file retrieval. Imagine trying to reassemble a puzzle scattered across a vast network, each piece identifiable only by a unique code. This is the challenge that NanoCheeZe elegantly solves, leveraging the inherent structure of the blockchain itself.
Remember those unique identifiers assigned to each chunk? These identifiers are not just random codes. They are meticulously crafted to contain within them the address of the next chunk in the sequence.
It's like a treasure hunt, each clue leading to the next until the entire treasure is found. The journey of NanoCheeZe, from its humble beginnings as an experiment on the Litecoin blockchain to its evolution into a sophisticated, multi-chain platform powered by smart contracts and tokens, is a testament to the relentless pursuit of innovation in the world of decentralized technology.
It's a story of pushing boundaries, challenging assumptions, and ultimately realizing the transformative potential of blockchain beyond its financial origins.
The millions of transactions etched into the ledgers of Litecoin, Bitcoin, and other blockchains stand as a testament to the viability and scalability of this groundbreaking file storage system.
The music streaming from the Decentralized Web, the software programs residing permanently on the blockchain. These are not just technological feats, but glimpses into a future where data ownership and control are no longer beholden to centralized entities.
The implications of this technology extend far beyond the realm of file storage. Imagine a world where artists can share their creations directly with their audience, bypassing the control and censorship of traditional platforms.
Imagine journalists and whistleblowers armed with the ability to store and disseminate information securely, free from the threat of censorship or manipulation.
Imagine a future where medical records are owned and controlled by patients, not institutions, accessible only with their explicit consent.
Imagine educational resources, scientific data, and historical archives preserved on an immutable, tamper-proof ledger, accessible to anyone with an internet connection, regardless of their location or socioeconomic status.